Hello guys, welcome to my YouTube channel. Let's solve today's Leetcode problem of the day. It's 7 September 2024 and the problem is linked list in binary tree. So the title is also suggesting that you have to find a linked list in the given binary tree. And if you see what the output output is written, either you can able to find the linked list in the given binary tree. So here if you see in the example one, you have given a linked list as well as tree, binary tree. So these are 4 to 8 and here also 4 to 8 have been matched in this binary tree, so you will have to return true. At the beginning you will have to have the knowledge of linked list as well as binary tree, how binary tree works and how linked list we iterate. So these are the basic requirements that you must know before solving this problem. And if you are good how to iterate the binary tree as well as how to iterate linked list, you are ready to solve this problem. So let's see the example number 2. These are given the head as well as these are the tree. These are the tree and this one is head. So you will have to find, these are the binary tree and you have to find this list of node. So here you will see 1, again a 4 and then 2 and then 6. Let's try a wrong path from here 1. So we will see that we found a match, so you will call a left call as well as right call. So first we will do the left call because 4 and 4 are matching, so we will again go to the left. 2 and 2 are matching, so again we will go to the, but 1 and 6 are not matching. So in this case there is a further node you have to explore, you need to explore. So you may go down further because it may happen that these set of node might be appearing just below this node. So you can't just return from here, you have to explore the further subtree. So maybe you can get the answer, so you can return that you have gotten the node from here and you return true. So here because the till here the tree is ending till here, so in this situation 1 and 6 are not matching, so we will return false in this, and return false and return false. You will reach here, from you will make a right call because 4 and 4 are matching, we will call this one 2 and matching, then left call 2 and 6, and these two are matching because you hit the last node of the secondary linked list. So in this situation you have to return true because you have already get the true, so you do not have to iterate the right subtree. So just return true and then true and then it will return true at the end. So these are the problem is all about. Let's see here in this example it is given false. Let's see here in the third example, maybe the graph are given for test cases. Sorry, number 3. So these are the test number 3, these are the head and these are the tree that is given. So 1 2 1 4 2 6 8 you have to find. So let's suppose 1 is matching from this node, so let's explore the 4 and then 2 and then 1. So these are not matching and no further subtree, so we will return false from here. So we will reach from here, then 4 4 and 4 4 and this 4 is matching this, I mean this 4 is matching with this, and then head will point to this 2 and then 2 and again the 6, 6 and 6, because no further is, because we couldn't be able to reach at the end of the list node. So from here it will return false, that we have not get the exact match as the element is given in the linked list. So return false. From here we will 2 and then in this part 6, you have to find a 6, but here we got 8 and here we got 6. So in this situation we also didn't get it, so we will not return from here. From here we again make a new call from here starting, because it may happen that you have the exact matching below this node. So we will again call, we will pass the address of this first node and then iterate it further. If we will get somewhere the exact matching, we will return true, and if it will not get the exact matching equal to the given list, in this situation we will return false. So this is all about the problem. Let's try to analyze that how we will solve this problem. So let's suppose you have given the list is 2, 4, 6. These are the list is given, and you have the node like 2, then 3, and then 4, then 4, and then again 2, and then 4, and then 4, and then 6. These are the node are given. So these are the 4. Actually, this one node is 4. So head will point to this node, head, and root will point to this node. So when, if we will make a recursive for, when, what will be our base case? So to make the base case, there there might be two base cases, like if head is like here, out of bound, like null, here it will be null. So if head will point to the null, it means that you have iterate all the node of the head and you find all the node in the tree, so you will have to return true. So first base or base case is if head equal to null, that means you have, so you have to return, this will happen, return true. Sorry, let's try to write exactly, return true. And if root base case, if root will be equal to null, return false, because head, if this base case wouldn't hit, then this might be hit. So in this situation, why a root equal to null, you have, we are returning the, here returning a false, because head, if head is not null and root have get a node where you will not go to further, not go to any further tree node. So in this situation you have to return false. These are the two base cases, and as I have already mentioned when I was explaining about the problem, that you have to make two calls. If if matches are found, like 2 and 2 are found, so in this case you have to you have to call left call as well as recursive left call and right call. So we will just call left call. In this situation we will, if head dot value will be equal to root dot value. So you will have to make a left call. Where left call you will pass head dot next and root dot left, as well as you have to similarly right call. So head dot next and root dot right. So these two call, and if a mismatch happens, like here, let's suppose you are here and you are here, these are matches, then you came to here because of this left, these this will satisfy this condition, then left call will be there and 3, and because the next is 4, so these are not matches are there. But we will, if you will see here that 2 4 6 node, these are the list exactly matching with this given list nodes. So you do not have to return false from here, you have to explore the further subtree. So we again make a call. So if these are happen, so you will have to these call, otherwise you will have to make an iterative call with a new iterative call, like you will have to call left. I will make a universal which will always point to this node. So let's suppose I have made a t pointer which is always the head and it will point to this node always. So in this situation I will pass t as well as root dot left and make a right call t root dot right. And in this way, if either of them, either this one, this one, any one of them will return true. Let's suppose a variable, boolean variable, that is k. So these are the operator. So if either of them, k or equal to ये k or equal to this one, k or equal to this, if either of them, these are the boolean k, these are the boolean variable k, initially it will be false. These are the or operator. So if either of the iterative call, recursive call, if either of the recursive call will return true, we will just return whatever the will be the solution, we will return true. But in this solution there is a problem that it will hit TLE, because I am making the 4 branches from here. I am making the 4 branches left, right, and from again I am starting from the beginning and again starting from the beginning and return case. So it will hit the base case. It will hit TLE. So to avoid the TLE, what we will do? We will do memoization. Whenever a root string, I will make a string which will contain root and head. If the map will contain this, I will make a hash map. If the map will contain this key, you do not have to iterate it further. the similar call to head to the previous node, and you will store this node if either it could be able to give you the false or true result. So based on the what value have been stored to this key, we will just return it. So this memorization you have to implement memorization so that you can avoid TLE. We will first submit the solution and then we will apply the memorization. Let's try to solve the problem now. Okay, so first you have to make a universal node. Let's say I have given the T, so T will point to head. Okay, and no, I will not. Right now I will not. I will make a method which will be, let's say, find. So it will take two parameter head and whereas tree node. As I have mentioned, there will be two base cases. If head equal to null, just return true. If root equal to null, you have to return false. Otherwise, if there is the matches, like if head dot val equal to root dot val, so in this situation you have to make a variable boolean false. So I will make left call as well as right call. Sorry. Equal to find root dot left. Sorry, first one will head. Okay. These are the left call. Similarly, on or equal to find these are the left call. So if instead of this you have to make a trace call from the first node of the linked list. So for this these are the next. I will make T okay, this is all, and at the end you will return found. Okay, let's try to call the return found. Sorry, find head as well as these two nodes are root. So I will pass the root. Let's try to these are many test cases. Let's reset it. So let's try to run our solution. Cannot get head here. So sorry, you have not the reference of head here. Here you will have to make T So these test cases has been passed. So if you try to submit this code, you will hit the TLE. Just try to submit it. You get the TLE because each time you are making a new tree, new recursive tree here from here. So you have to implement memoization here on the basis. You also have to think about that what will be the key, so that it make unique and reduce the similar recursive call. So you will see here that root and head, if you are at the specific root and combination of specific root and head, on the basis of specific root and head, you can make it as a key and can use if the same combination of head and root will be found. You just have to return what value have been stored corresponding to this key, and in this way you can avoid TLE. So let's make a hash map. I will make it a string versus boolean, sorry. And so this will be the map. If I will store here part make a string plus and plus root comma. For this key you have to store the form, and if you will already been iterate to this combination of head and root, you just have to return what value have been stored to this corresponding node. Okay, let's try to run our solution. Let's try to submit. Let's try to run these test cases that was giving TLD to us. So these have also been accepted. Let's try to submit the solution. So you can see that our solution have been accepted, and this beats 5.1% of the people that have been submitted in Java. So this is all about the today's Leetcode problem. So if you have any query, any suggestion, you can comment me in the below comment section. So if you like my videos and my explanation, you can appreciate me by following my YouTube channel. You can hit the like button, and if you have the friend who are interested in CP and DSA, you can also share with them, and please subscribe to my YouTube channel. Thank you.